Mysterious temperature changes on Neptune. Nearly 2 decades of observations have shown that Neptune is experiencing surprising temperature changes. Analysis of the collected data revealed that first, despite the arrival of summer in the southern hemisphere, the temperature dropped by 8 degrees Celsius, and then suddenly jumped by 11 degrees Celsius. Scientists cannot fully explain this mystery. On the most distant planet in the solar system, just like on Earth, there are seasons. However, since a year on Neptune is about 165 Earth years, the season there lasts about 40 years. It has been summer on Neptune since 2005. Scientists from the University of Leicester in the UK and from NASA's Jet Propulsion Laboratory thought this was a good opportunity to check how temperatures are changing on Neptune. For this purpose, they analyzed nearly 100 infrared images of the gas giant collected over the last 17 years of observations. The data showed that between 2003 and 2018, as the planet's southern hemisphere slowly entered summer, Neptune's global temperature dropped by 8 degrees Celsius, but then, by 2020, temperatures at the South Pole jumped by as much as 11 degrees Celsius. Scientists don't know where such temperature fluctuations come from. The description of the observations was published in the Planetary Science Journal. Neptune is the farthest and 8th planet in our system. It is 17 times more massive than Earth and slightly larger than its twin Uranus. It is the 4th largest planet in the solar system and the 3rd largest in terms of mass. The gas giant has 14 known moons, the largest of which is Triton, which, unlike the planets and most moons in our solar system, has a retrograde motion, indicating that it was once an asteroid, probably in the Kuiper belt, but was pulled into orbit Neptune by gravitational interactions. Recent studies of the most distant planet in the solar system have discovered something unexpected. The team of scientists combined all existing images from Neptune's thermal cameras, which measure infrared radiation emitted by astronomical objects, taken over the past 17 years by observatories around the world, the European Southern Observatory's Very Large Telescope, the Gemini South Telescope in Chile, the Subaru Telescope, the Keck Telescope and the Gemini North Telescope, as well as images from NASA's Spitzer Space Telescope. By analyzing the data, scientists were able to show the most accurate picture yet of trends in Neptune's temperatures. But to their surprise, this collective data showed a startling drop in temperatures at a time when they should have been rising. Scientists emphasized in the publication that reliable thermal imaging of Neptune began in 2003 and shows globally averaged temperatures in the stratosphere of the gas giant. Since then, specifically between 2003 and 2018, global temperatures in the stratosphere have dropped by about 8 degrees Celsius. But then, between 2018 and 2020, global temperatures rose by 11 degrees Celsius. This change was unexpected. Because we observed Neptune during its early summer in the southern hemisphere, we would expect temperatures to slowly increase rather than decrease, said Dr. Michael Roman of the University of Leicester, lead author of the paper. Neptune's orbit is 4.5 billion kilometers away, so the average temperature on the gas giant is about -220 degrees Celsius. The little heat the planet has comes from internal processes. Tracking seasonal changes provides insight into the evolution of a planet's atmosphere, but it's not the easiest thing to do. This type of research is only possible with sensitive infrared images from large telescopes such as the VLT, Very Large Telescope, which can clearly observe Neptune. And these have only been available for about 20 years, explained Lee Fletcher from the University of Leicester, co-author of the research. Scientists currently cannot explain the observed temperature fluctuations on Neptune. They already knew that the gas giant has a warm, for Neptune, polar vortex. But they believe it is not responsible for it. The reason may be the variability of the chemical composition in the planet's stratosphere, solar activity, or even some weather phenomena. Our data covers less than half of the season on Neptune, so no one expected such large and rapid changes, admitted Glenn Orton from the Jet Propulsion Laboratory, co-author of the publication. Scientists will look for answers in the coming years. Observations using the newest observatories currently under construction, such as the Extremely Large Telescope, may shed more light on the observed fluctuations. More data should also be provided by the recently launched James Webb Space Telescope. Men lose their Y chromosomes as they age. This affects their lifespan. Statistically, men live slightly shorter than women. As it turns out, this is partly influenced by factors that are difficult for men to do anything about and that are even difficult to measure. They are related to basic differences between women and men. At the chromosome level, as men age, it's not just their hair that they lose. They also begin to lose Y chromosomes from their cells. Scientists had previously linked it to a long list of diseases and a higher risk of death, but the evidence was circumstantial. Now they report that when they removed the Y chromosome from male mice, the animals died earlier than their Y chromosome-bearing counterparts, probably because their hearts became less efficient. According to a new study published in the journal Science, the gradual loss of the Y chromosome in men as they age leads to scarring of heart tissue and increases the risk of fatal heart failure. As we know, the basic difference between women and men is that women have two X chromosomes, while in men they are X and Y, and it is the content of the Y chromosome that may be the source of problems. Or rather, the level of this content. It turns out that during life, some men gradually lose their Y chromosomes. This especially applies to smokers. This occurs especially in cells that undergo frequent replacement, such as blood cells. Interestingly, however, this does not affect the cells responsible for reproduction. And therefore the children of these men do not inherit this tendency. But what impact can this have on health? To assess this, scientists analyzed the results of analyses collected in the UK Biobank database. The conclusions are quite disturbing because it was found that the loss of the Y chromosome was often associated with the likelihood of developing heart diseases, such as cardiovascular disease or heart failure. This, in turn, results in a higher risk of death. Researchers from the University of Virginia conducted research on mice whose genome was appropriately modified. In this case, it was also found that the gradual loss of the Y chromosome is dangerous for the heart. The risk of scarring increased, and the immune system's reactions to inflammation led to tissue fibrosis throughout the body. This resulted in earlier death of the tested mice. In this situation, it would be advisable to determine which men have lost the Y chromosome and initiate effective treatment. However, it turns out that it is not that simple. It is true that Lars A. Forsberg from Uppsala University, Sweden, developed a PCR test. This type of tests are also used for COVID-19 diagnosis, but unfortunately the possibilities of using it are limited to the laboratory. However, it is hoped that with the appropriate level of interest and need, these tests would become more readily available. How could the effects of the loss of the chromosome in question be mitigated? Current methods of treating idiopathic pulmonary fibrosis provide some hope here. One of the drugs used is pirfenidone, which has already been approved by the U.S. Food and Drug Administration. In addition, research is also being carried out on the possibility of using it in the treatment of heart failure and chronic renal failure. Dr. Kenneth Walsh of the Department of Cardiovascular Medicine at the University of Virginia believes that patients who have loss of the Y chromosome might respond well to such treatment, which could improve their health and increase their life expectancy.